Hi, welcome to the Betaverse, our vision for the future. Over the last few weeks, we have quite literally revolutionized the way you see the world. It started off as a lab project, but it's evolved into so much more. Imagine being able to see the world with all the data you need right there in front of your eye. Our project was to develop a revolutionary AR set of goggles that uses the phone camera to overlay the data on the world. It also is controlled by an incredible ergonomic handset consisting of an FPGA, Arduino, and battery pack. We use this controller and use the buttons and the switches and the accelerometer to control what features are shown on the display. The controls are all done through moving your hand and pressing switches. When you raise your hand, just like you would with a normal phone to see the map enlarges so that you can see the locations of all the other users on the system. Furthermore, when you press the switch, you can also see that the text shows up, like latitude and longitude and altitude and the time and date. When you let go of the button and you remove it, the text goes away. The entire system is controlled through pressing that button. When you press it and hold it down, eventually the system will turn off and the FPGA will recognize this.
My computer is currently showing the data being received serially from the FPGA to the Arduino via the serial communication responsible by these wires. When we change the switch, press the button and rotate the device, the Arduino should pick that up and display it on the console. When I move the switch to on, the switch status should change, which it then does. If I turn it back off, the switch should change back and turn to 0. Similarly, when I press the button switch should be recognized and turn to 1, which it does. When we let go of the button, it then lets go and turns back to 0. The last feature that we have is for when the Arduino and FPGA combination rotates. At the moment, it is currently not in a held up position, and so the status is 0. But when we rotate it, it should turn to 1, which it promptly then does. When we then rotate it back again, it should turn back to 0, which again, it does. Now that's pretty cool, but it's not all. The Arduino and FPGA are connected via this Wi-Fi shield to my personal hotspot, and from there, it's connected to the Amazon Web Services EC2 instance. What this does is it takes the information serially and then sends it off via TCP to a server. This server then takes that data and stores it in a database so that the phone can retrieve the data and use it to alter the display. When we move the switch up, the serial communication will send it to the Arduino, it will send it off by TCP to the server will recognize that and store it in a database. When we turn it back off, the similar thing happens in the opposite direction. When we move the button from the status of off to on, after holding it down, the server will recognize that and store it in the database. And similarly, when we let go, it will turn it back from 1 to 0. The final status is when we rotate the device, we want the map to open up. And so how are we going to do that? Well, at the moment, it is currently imagining by your side, and when you rotate that, the accelerometer data gets evaluated and turned into a rotate status, which gets stored in the database. So when I rotate it up to see the map, the Amazon Web Server recognizes this and displays 1 for rotate. And again, if I turn it back to the side, it recognizes that and turns back to off. We've also included a mechanism for the server to send data back to the Arduino and then back to the FPGA, and coded the FPGA to respond accordingly. When we turn the button, we press the button on, the FPGA should turn on, and by doing this, it sends data from the FPGA to the Arduino to the server to the database, back to the server, back to the Arduino, back to the FPGA, and changes the status to on. Similarly, when we turn it off and press the button, the data goes to the Arduino, to the server, to the database, back to the server, back to the Arduino, back to the FPGA, and it turns off, similarly showing the LEDs turning off and showing off on the 7-segment display. We also have a port which is responsible for the phone reading from the database. This is important because we want the phone to read the status of the device it is connected to it so that it can update the display accordingly. When we change the switch status, for example, that gets sent from the FPGA to the Arduino to the server, which will update accordingly over here, and the phone will detect that and read from it, as can be seen by the change from switch from 1 to 0. Similarly, if we press the button, the phone then detects that and reads from it, as is displayed now. The final feature, obviously, is the fact that when we change the rotate status, that data also gets sent, as I've explained already, to the server, to the database, which will update up at the top, and the phone will immediately read that data and detect the change. Here you can see the map open with all 4 ports of the servers open behind it. Currently we're looking at the GPS capability of the device. Currently you can see my location in my flat in London. When you zoom out, you can see someone else's location over in Imperial College. This shows the multiplayer aspect of the game, where a user's location is sent to a database so that any other user can read their location.